but it is a general format because we are studying the types of CPU organization, right? Here may be 8085, 8086, 8088, whatever. Okay, so STA means store. We have to write store, not STA. Remember it. Okay. Okay, let's start. In one address instruction, you need to remember two things. This is implied accumulator, and one address instruction you know already. So it is implied accumulator. Here, if I write add B, that means the content of accumulator and the content of M of B are added and the result is stored in accumulator. Okay, fine. Now, if I want to perform A plus B, then I have to first load A. Okay, that is why I'm writing load A. After writing load A, now accumulator contains content of A. Okay, now I can write add B. Clear? This is very clear to you, right? Now it is our expression which I'm evaluating. Now think about it. If I start loading C, that means the accumulator will be containing the content of C. So right now accumulator contains what? A plus B. The result of A plus B. It is containing in accumulator, right? So we should temporarily store the content of accumulator, that means A plus B, into some location temporarily. After that I can load C. Otherwise the A plus B content in accumulator will be lost. Clear? That is why I am using store instruction in next. Okay? Clear? Now the content of accumulator A plus B is stored in some location, say P. Okay. Now I can load C. Then add D. After that I'm writing. Right now accumulator contains what? C plus D. And A plus B is residing where? In P location. So I can multiply them. Clear? MULP, that means accumulator is containing what? C plus D, and it is containing A plus B. Both are multiplied and the result is stored in accumulator. Now it's time to store. So store means from accumulator to main memory, some location. That is why I'm writing store X. That means from accumulator I'm storing it into M of X location. Clear? Zero address instruction. See, zero address instruction means stack organization. Right? Now, in stack organization, which instructions are available? Push instruction, pop instruction, and zero address instruction. In in evaluation procedure in stack organization, you saw that whatever expression it is, that means it is an infix expression, right? So we have to first convert it into its corresponding postfix expression, RPM, right? Let's make it. X is the destination where we have to keep it. Okay, let's draw a stack here. Okay, let's write it. Instead of Q I'm writing X, and instead of P I'm writing this. Okay, our first step is to put an opening bracket here and a closing bracket here. Okay, and scan or read from left to right. First we encounter opening bracket, push it. Next we encounter operand, add it to this A. It is operator. At the top of the stack, there is no operator, so push it. After that, we meet B. Add it. Closing bracket. That means we have to pop this, write it, pop this, no need to write. Again, we meet asterisk. That means operator. At the top of the stack, there is no operator, so push it into the stack. After that, opening bracket, push it. C, operand, add here. Plus operator. There is no operator on the top of the stack, so push it. D is an operand, so add it to RPNX. First closing bracket, so pop it, plus next closing bracket, pop them. So this is our corresponding RPN, right? You remember the evaluation procedure in stack organization? Whenever we encounter operand, then push it into the stack, and when we encounter an operator, then we have to pop to. It's not that we have to, it automatically it is done. When we encounter an operator, the two topmost elements are popped from the stack, and that operation is performed in between those operands, and the result is pushed automatically into the stack, right? And we will write this in RTL. Okay, so first we encounter A, means it is operand, so we have to push it. So I'm writing push A, right? Push A means the content from location A is pushed onto the top of the stack. So top of the stack, TOS, top of the stack abbreviated, contains what? A. Okay. Next we meet B. It is an operand, so push it. Next is what? It is a plus sign. That means add. See, it is a zero address instruction. In stack organization, we need to mention only the opcode, operation code. What is to be done? It is an addition, so write add only. That means top of the stack contains A plus B. Okay. Next is what? We meet C. That is an operand, so push it. I'm following the evaluation procedure in stack organization only, nothing else. C. Next is D. It is an operand, so push it, right? Next we meet plus, so write just add, right? Next is what? This asterisk. That means multiplication. Write MUL. Now is it finished? No. We have to store this result into X location. Now the stack contains, that means stack contains, or top of the stack contains, same here, this result. We have to pop this and store into X location. That is why I am writing pop X. Okay. In the PDF file, this X is missing. Please write it down. Okay. So top of the stack is popped into aim of X location. Finished.